Hi, welcome to our talks. My name's Mark. I work in the developer relations engineer, and so Karin and I are going to be talking about how do you go about building user-facing analytics, sometimes called real-time analytics, using Kafka and Pinot. So I guess you can introduce yourself, and then Karin's going to start the talk.
Okay. So I'm Karin Wolok, and I lead our developer community at StarTree. And I'll start off the talk, and then we'll also do a demo in the middle at some point. So that's going to be the most exciting part, I think. OK, so just to start off, we're going to just talk about the types of analytics that there are, the real-time analytics, right? Or just analytics in general. Now, generally speaking, there are three types of analytics. The first one is dashboards and BI tools. This is probably the most commonly used one. And it's very often it's used for internal purposes. And then, like BI analysts and things like that, right? The second one is user-facing analytics. And user-facing analytics is basically when you are building applications and you're providing your end users the ability for access for real-time analytics. So you're providing them with real-time analytics. I'll dig into that a little bit more shortly, but that's just kind of like the high level. And then the third one is machine learning, basically when you're pulling analytics and then you're feeding it into a system that has some kind of automated or machine learning process behind it. So things like anomaly detection or fraud detection and things like that, anything that might be automated. So those are, like, generally speaking, high level, the three types of analytics. So dashboards and BI tools, as I kind of mentioned, a lot of organizations will use this like for internal purposes. They can be real-time or kind of batched. It doesn't have like as much of a, it has needs for real-time, but not as much as some of the other ones. The second one is user-facing analytics. So digging into this a little bit more, I'm going to, actually, you guys can see this. So when you're doing things like LinkedIn, like who viewed my profile, you're able to see who viewed your profile at that time, and you're able to, basically, there's actually the feed here, which is also kind of pulling in real-time analytics. Doesn't matter. I think you guys have it, the point. I'll dig into it, a couple more examples of it as well. And then the third one is the machine learning, which is this one's like automated. It could be like if there's something going wrong on your pages, all of a sudden page views are down or something like that, and you need to have an automated system, either take action or alert you, the human. So why should you care about real-time analytics and real-time user-facing analytics? So over time, companies have kind of transformed their businesses and actually even created products that are built around real-time user-facing analytics. So I will dig into this a little bit more, but it started kind of using analytics internally, and then slowly we're empowering our end users by providing them with their own analytics and you can actually monetize these types of applications or products. So actionable insights. This kind of goes back into like how a lot of businesses are actually transforming their business by providing their end users with real-time analytics. So you can provide your end users with real-time analytics, which is a great thing. But another additional thing that you can also do is you can actually create the ability for a user to take action upon seeing some kind of insights that are coming in, right? So that's like where you're giving your users the power. You're basically empowering your users to be able to take action. And that's what actionable insights are. So you can actually build full applications that are based off of real-time analytics to your end users where they can then take action, which empowers them to be able to do more things, which is depending on what you're building. That's kind of the benefit of that.
Yeah, so we can talk about some of those on these next examples where having the data like live and that we can actually do something that maybe we wouldn't be able to do if we didn't have it.
Right.
So
thank you for adding that. Okay. So some examples of real-time analytics. So I'm going to go over a lot. LinkedIn has this a lot, so I'm going to go over a couple different use cases at LinkedIn. So the first one is who viewed my profile. I'm sure most of you guys are familiar with it. Actually, this number, I think it's over 800 million users right now on LinkedIn. So you could see who viewed your profile in real time. You also have a lot of dimensions. You can kind of slice and dice it, by countries and companies and all that kind of stuff. So you have the ability to do that. So that's like forward-facing for the users, right? It's like you could do it as like a premium feature or something to be able to access that in full. Another example of user-facing analytics at LinkedIn. This is slightly different in terms of like you're not offering them dashboards or anything like that, but the requirements of building real-time analytics systems are still here. So like a news feed. So what happens when a user opens up their home page, they're basically querying this massive database to be able to pull from all the historical data and all the new data. Who posted now? What have you already seen? How can I make sure that this is the freshest, most relevant information that I'm giving you? And this is also built off of like real-time analytics systems, which is basically forward-facing for your end users, right? Your end users are the ones that are doing the queries.
Yeah, and then for this one, the actionable insight is we want you to interact with the post. Like we need to show you something, and you're like, oh yeah, that's an interesting person, or they're talking about something that's interesting to me. I'm going to like it. I'm going to comment on it. I'm going to share it. Like for LinkedIn, those are the 3 things they want you to do.
Right.
But it doesn't mean you have to be LinkedIn to use it. It's anywhere where, hey, the data that's coming in now allows me to let the user do something that they might not have done otherwise.
Right, and that's where like the value is, right? It's like you want your users to interact, you want them to be stuck there, so like, the more relevant the information is, things that are not redundant, new, fresh information, that's where the value comes in, right? So thank you for clarifying. This actionable insights thing is kind of a big part of it. Another example is the like LinkedIn Recruiter, where they offer businesses the ability to access real-time analytics about all like this internal data that they have. Same things, there's a lot of dimensions and complexity in there, but they literally created business models and products around offering their end users real-time analytics. Another example of real-time analytics is Uber Eats. So Uber Eats has they have like this restaurant platform where it's forward-facing to the restaurant owners, and the restaurant owners have the ability to see, all like their profits, their missed orders, top-selling items, feedback, things like that. Now, one of the actionable insights that like on a restaurant owner can do, right, is like when they have the ability to access this information in real time, is like maybe they see all of a sudden there's like bad reviews coming in because the orders are taking long or something like that, and they have to take action on it immediately. That's like kind of the benefit that you can provide them by providing them real-time analytics.
Yeah, so in that case, if they had like a missed order or an inaccurate order, the person who's obviously getting that is already annoyed with them, but they can try and like at least soften the annoyance and go, hey, look, we'll give you a voucher, we'll give you that free. It's almost like, like if you've ever been in a restaurant and they mess up your order, they generally go, hey, look, you can have that for free. Like this is like almost like scaling that, like the really good waiter or waitress in a restaurant to, effectively like a digital food delivery.
Right, which then it kind of empowers your users and gives them a better experience because they're able to give their customers a better experience, right? So this is like business to customer to customer. Okay, so this is a really interesting use case. So the example of real-time analytics at Stripe. So they do have a lot of use cases for real-time analytics, which are the ones listed here. I'm not going to read them out all to you because they're pretty straightforward. But one that I want to specifically point out is their tracking financial event data at Stripe. So Stripe has dozens of engineering teams, right? And they're all working on like different kinds of projects, different countries, different currencies, different banking integrations. But ultimately, all this data needs to be consolidated and utilized accurately, right? They have to have a lot of precision within this data that they're moving forward so they can move it over to like the accounting team and the finance team, like fraud detection and all that kind of stuff, and the data science teams. So they ultimately have to figure out how to like connect all these pieces of data that are coming in, all these financial events that are constantly coming in and changing, and then being able to funnel it to make it usable by these like other teams on it's a data flow kind of, right? The data flow. To be able to make it usable within real time, right? It's like, if there's fraud happening, you need to know now, not like 3 hours from now. So this is, I think, is a really interesting use case. This is also some of like the challenges that they face in terms, kind of I was mentioning, like it's a financial company, so there's a lot of sensitivity there. Like they have to have really high precision and granularity. Everything needs to be reproducible and all that kind of stuff. They also have a lot of compliance and security requirements and things like that. So there's a lot of complexity here. I really like this use case because this is not necessarily user-facing, but like, you know, in terms of like the real-time analytics and the importance of this data flow, bringing a data in and pulling it out is highlighted pretty well here. Properties of real-time analytics systems. So when you're building out real-time analytics systems, high level, there's like 3 things that you ultimately need. The first one is speed of ingestion, right? You have to be able to bring any of these events or this data that's coming in, including, it could be also batch, right? You have to be able to bring it in real time, right? The second one is you have to be able to query that data in real time. So you're pulling this data in, but it also has to be accessible in real time.
So real time in the second one means, like, imagine you're serving a query to a website where there's a user. They're not going to sit there and wait. Like I guess in a back-end analytics system, you can maybe wait for 10 seconds, and they're like, oh, I'll sit here, I'll try to drink some coffee and get the result. If it's on the LinkedIn website or if it's on like the Uber Eats dashboard, you can't wait that long, right? It has to be like in milliseconds to come back. So that's the idea. So we want to get the data from our streaming system available like as quickly as possible for people to be able to query on that fresh data, and then when they do the query, the result needs to come back as quickly as possible. So both of those things need to be fast. And then the last one is that it needs to scale up to users, right? So if it's an internal system, then maybe we have like 5 users using it, and then there's a very different type of architecture to build that type of system. Whereas if we're building something that needs to be scalable to like a website's users, it could be tens of thousands of people. Like, so it could be doing like lots and lots of concurrent queries at the same time.
Right. So a lot of queries coming in at the same time. Very often, it could be from like your end users refreshing their news feed. Those are all queries coming in at the same time. At scale, right? So going back to like, well, LinkedIn use case, I guess we'll come back to it afterwards with the scale side of things. Okay. So do you want to do? Yeah.
So we want to just quickly run through like what do you need to get out of the way? What do we have if we're building this type of system? So sort of around the edges we can see like these are the properties that it needs to have, and then in the middle, so we've got Apache Kafka and Apache Pinot. I guess you kind of know that because those 2 things were in the title. But effectively, like Pinot also works with other streaming systems. They have people doing stuff with Kinesis. There's also PubSub, and then Pulsar, and then Red Panda is one that people have been picking up recently as well. But for the purpose of this talk, we're doing stuff with Kafka. And so that's going to help us to achieve all the things that we've kind of got around the edge. So I'm not going to do like a big dive into Kafka, but just for the purpose of this talk, just to quickly explain what it is in case you've not come across it before. So for our purposes, it's a queue of messages, and they're generally going to be events, and they're going to be JSON events. So we've got like let's say for the purpose of this talk, an infinite stream of these events that we've got coming in from somewhere. We've got a producer that's putting those events onto topics. So topics is like a type of event. They can be partitions. That's kind of what you see like on the rows, so we can kind of scale that out, so we can have lots of producers publishing messages at the same time. And then on the right hand side up here we've got consumers who are taking those messages off. There are also consumer groups, so this is where you're kind of tracking like where have I got up to with consuming the messages off each of those topics. That's not of interest for our talk, but it is of interest if you're doing Kafka in general, in the way that Pinot works with Kafka. It kind of keeps track of its offsets on its own, so it doesn't use consumer groups, but we'll just put it there for completeness. And then Karin will quickly run through Pinot.
So Apache Pinot is an OLAP data store. And basically what it does, it kind of sits in between your different systems. So you can pull in data from a variety of sources. So like stream and batch, like ETL kind of thing. And you can pull it into one collective view. And it actually like merges these things. It has pre-aggregation and special kind of indexing to then make all this data that you've pulled in real time, batch, not obviously real time, but like the streaming data, make that data available for queries in real time at high throughput. So when you have a lot of queries coming in at the same time, hundreds of thousands in some cases, you're making that data accessible. And also, like, one of the big benefits, aside from being able to bring in all these different data sources together, is that you also have the ability to, it has a lot of dimensionality. So if your data is pretty complex in terms of the queries that you're doing, and you need a lot of queries that are complex in real time, that's when you would use something like Pinot.
Cool. So let's just quickly run through the architecture of how it goes about achieving this. So on the bottom left-hand side, we've got our streaming system. So we've got Kafka. The different color arrows indicate like a different partition. So like imagine we've got 4 partitions here. And so we're wanting to get the data in. So in Pinot, the queries are served by servers, and the data is ingested down here. And then we also have this controller up the top, and that's used for managing the cluster. So it takes care of like all the metadata on the cluster and making sure like which servers are handling which partitions coming from Kafka. So that's sort of managed up the top. And it's all stored in Zookeeper, and so there's a bunch of code in Kafka that's sort of handling all that for you, and you can kind of see like so it talks about segment is short for segment, so this is the unit of storage in Pinot, and then it's mapping different segments to different servers. And if you were doing this in a production setup, you'd have multiple copies of them on there. So you can kind of see like this is how it would go. Like if you add in, and then if you were to add in a new server, it'll go, okay, well now we can spread out those segments into another place as well. And then the other component that we have is called a broker. So we've got 3 things. We've got the controller, the broker, and the server. So controller, managing the cluster or the metadata. If you try to add like a new segment, it takes care of that. Server, serving the queries, and then the broker is actually where that's where the query comes from. So if you've got like a client, you would send your query to the broker, and then the broker works out. I think we might have a slide for that. Where do I need to send the query? So it knows like, okay, this is where like your query needs to go to a server that has a particular segment. Okay, I can send it out, and then. I thought we had, so maybe we just say it. So it's basically doing a scatter gather on the results. So it gets the results. So it might have multiple servers go, hey, here's the results from my particular part of the data, and then the broker's responsible for aggregating everything together. So we want to just quickly do a demo, like just on my machine, showing how all these pieces glue together and the type of thing that you could build with it. Obviously, keep in mind that the scale of this demo is obviously a lot smaller than the examples that Karin was talking about. The stuff people were doing there is often in tens of thousands or more events per second. We're not going to be operating at that scale, but just to give you an idea. So we're going to build like a little application. So we're going to query a streaming API. We'll get the data into Kafka, run it into Pinot, and then we're going to use another tool called Streamlit. So I don't know how many of you have heard of this, but Streamlit is it's a Python web application, I suppose, for building like data-intensive front ends, and it generates. I guess it's kind of doing a similar job to like what React or something would be doing in JavaScript, except you're only writing Python code, and it's kind of handling everything else for you. So we're gonna work with. It's quite kind of. I guess some of you might know this. It's kind of tricky finding open streaming data sets that aren't like hidden behind like some massive paywall. But this is one of them. So the Wikimedia recent changes feed has like a stream of server-side events that show you what changes people are making to Wikimedia properties. So it kind of covers like all the different language. Wikipedias. It covers like the structured data store that Wikipedia have as well. And then, as I say, it's on a HTTP API, and it's just sort of sending you events. This is an example of what you get. So basically, if you open, I'll show you in a minute, the URL that we have, you basically just get loads and loads of events that look like this. So they all have an event, which basically tells you it's a message. You have an ID, and then the bit that we're interested in is this data down here. And for our purposes, this is just it's just a nested piece of JSON. So you can kind of see like some of the things may be recognizable. So you can see like there's a timestamp in here in the middle. It tells us what server processed that request. It tells you what comment they left. It's got an ID. It tells you what domain it was done on. So this change was done on the English Wikipedia. And then the title of the page. So there we go. Bosmansdom High School page was edited here. Right, so let's have a look. Let's see if we can, let's get this working on the machine. So let me just quickly, so we'll just start. Like, I'll just show you how big does this need to be? Let me get it a bit bigger.
Maybe a little bigger, yeah. Is this good?
If you're at the back, how big?
Can you see it?
Bigger?
Bigger.
More?
Bigger.
Enough?
Good?
Yeah?
You got
all right.
thumbs up.
So we're doing everything on locally on our machine, and Kafka and Pinot have Docker images that we can use to do all this. But in production, people are generally doing stuff on Kubernetes. But for the purpose of this, we'll just do it all using this Docker Compose script. So as I say, Pinot uses, what's wrong?
It turned off.
Oh, did I hit? What did I do?
What did we do? This is just like standard happens when you do a demo, right? Like something's got to go wrong.
Oh.
If your demo doesn't go wrong, you have to be able to lose the
I
connection
did
to
do
the
something.
screen.
I hit the button with my foot. All right, I'm going to sit like this now. So, so we've got Zookeeper here. So both Kafka and well, actually, like one version of Kafka is attempting to move off Zookeeper, but for the purpose of this one, Kafka and Pinot are both using Zookeeper to manage their metadata. So we've got Kafka here. You can kind of see, like, we've got a host name. We indicate where it's going to listen for messages, and then we've got our three different Pinot components. We've got the controller there, we've got the broker, and then we've got the server. Only interesting thing really to read on here is this data directory here. So when Pinot is storing data, generally, like, it has a copy. Like on each server, they have a copy, like on instance storage. But then it also has a concept of something called the deep storage, which is like the source of truth of each segment. Usually, people will be putting that on S3 or HDFS or Google Cloud Storage or some sort of other storage system. For the purpose of this, I just put it into this. I've got a mounted data directory in this folder, so we're just storing it in there. And I'll show you how that works while we get on. So that's the Docker Compose that we're working with. So let's just start that up while we're waiting. So what I want to show you now, so that should hopefully get everything up and running. So we'll just minimize that for the moment. The next thing that we need to do is have a look at the streaming API. So if we copy this into the browser. This is what the Wikimedia feed looks like. So you can see there's loads of events coming in, loads and loads and loads. You can't keep up with them. So this is what the data that we're processing looks like. So I'll just close that for the moment. To process this, you can use. So we're doing everything in Python in this demo. So we need to use this server-side events client. So basically, it's just putting a wrapper around a requests get request, and then we get a stream of values. So if we open up let's open up another tab. So that file is called wiki.py. And it'll be the same, like it's the same data as what we saw before, right? So we're just getting streams of this stuff coming through. Like we're literally just printing it to the screen. So let's stop that for the moment. What we want to do now is instead of printing it to the screen, we obviously want to move it into Kafka, right? So that was the middle of our diagram. So Kafka's sitting at the center of this real-time analytics application, and so we have another file to do that. So if we have a look, so it's kind of similar to before. So this bit's all the same. So this code is all the same. So I want to get my stream of events. What is different is that we've now wrapped it in a while true loop, because I noticed that sometimes when you were calling that API, the connection would drop. I don't really know why. I couldn't find anything on the internet that said how can you stop it from doing that. So I was like, okay, well I'll just catch it if it disconnects, and we'll just start again. And then the other thing that we're doing is we've got a Kafka producer sitting here. And so with the Kafka producer, you need to tell it where is Kafka running. So we say localhost 9092. And then when we get each event, we put it on. We use the producer. So remember the diagram. We have the producer putting the messages on, and then we're going to have a consumer taking the messages off. So we haven't got to the consumer bit yet, but the producer's putting the messages on. There's going to be a topic called wiki_events, and then every 100 events, we're going to write out to the screen, "Hey, I got some events," and we're going to flush it. So that flushes it to the disk in Kafka. If you were to just run that how it is, and there's no topic created in Kafka, it will create you a topic with that name with one partition. But since we want to be able to see, like, what does it do with multiple partitions, we're going to just create create that topic. So let's just do that. So create our topic. Doesn't like that I used an underscore, but we'll carry on. And then we can have a quick check. Let's just quickly check that it's created it properly. So this command here, it gives you the offset. It's like, where have you processed? Where am I up to in the messages that have been published onto each partition? So you would expect, right? We haven't put any data in, so they're all on 0. So we've got 5 partitions, all 0. So what we can do now is we can run that wiki to Kafka script, and it will start to put some messages on. So let's just open a new tab so we can have a look. Yeah, so there we go. So we've got 100. And if I put a new one, I'm just going to put this down a bit. And we'll open this on another tab so we can have a look how many messages have we got on each partition. So there we go. So we've got 100 on the first one, 108 on the second one, 99 on the third one. So we're using the key, which is the ID of the message. So they basically can pretty much go anywhere. We can also have a look at the actual messages themselves across all the partitions. So we could call the Kafka console consumer and say, hey, show me the messages. And this is going to be really similar, right? It's just going to stream everything. So there you go. There's all the messages. It's not particularly insightful, but those are all the messages. So we know that we've successfully got it. We went to the Wiki API. We got it into our Python application. We could print it out there. That worked. Now we've got it into Kafka. It's printing it out there. It's worked. So we kind of got it all the way. So streaming application part of the demo is working. Now we need to get the last bit working, which is, OK, we want to get it into Pinot so that we can actually query that data. So what we're going to do is we're going to let's just have a quick look through how would you go about creating something in Pinot. So Pinot works is pretty similar to relational database in the concepts that it uses. So we have a table, and then it has a schema, and the schema can be defined using this JSON file. We can define dimension fields. So those are generally like the metadata that you've got. So we've got the ID, the wiki, the user, the title. If you would have, and then the next type of field you would have is metrics. If we had like things that were some sort of count, you would have a metric field. We don't really have that here, but if in other use cases you might. And then we pull out date time separately. So we have date as a separate field. And each of these fields is kind of treated separately by the storage engine. That's the reason for having them separate. And then you can have so you have a schema that basically defines, hey, there's going to be some data in this shape. And then we have a table that uses the schema. So your schema name is called Wikipedia. We've got a table over here called Wikipedia. You need to indicate, so it indicates that it's a real-time table. So I guess just to recap what Karin was describing before, Pinot lets you have real-time data, so stuff coming in now. So that means you're connecting it to a streaming system. But it also lets you backfill data. Like say we had somewhere else the data for Wikipedia for like yesterday and like the previous few months, and we want to load that in as well. We could backfill that, and that would go into an offline table. So batch data into an offline table, real-time data into streaming data into a real-time table, and then you can query them both together. So it will take care of making sure that those two data sets combine. And then it has like a way of like working out, okay, at what timestamp do I need to look in the offline, and at what timestamp do I look in the real-time? And then the only other thing that's kind of interesting here are these 4 lines here. So we're telling it, hey, my streaming system is Kafka. The topic name is Wiki Events. The broker is sitting here. So Kafka Wiki is the name of the Docker container. And then we've got to tell it like which port it's on. If you were really like paying close attention to the ports, if you're outside Docker, we're using port 9092. That's what we're using from our other script. But then inside Docker, we're using 9093. So Kafka lets you kind of define both of those. We tell it it's a low-level consumer, and that means that it's able to process multiple partitions in parallel. So Pinot is using like effectively conceptually one consumer thread per partition. So if you want to scale it, you have more partitions on the Kafka side. And then down here we've got we've defined some thresholds. These are way lower than what you would have in production, but just for the purpose of the demo. And this is where so when you're creating a segment in Pinot, so that's like the unit of work. And we'll go through this afterwards, like in a bit more detail. So segment has all the columns, some of the rows. When it's consuming the data from Kafka, those segments will have the data from those segments will be in memory, and then when it reaches the threshold, then it flushes it. So we're saying there's a there's a threshold of 1,000 rows, if not 24 hours, if not 100 megabytes. So it's that threshold is per server. So since we've got 5 partitions, we're putting everything on the same server, it's going to be 200. So every 200, it's going to flush it, which is way more frequently than what you'd normally do, but for the purpose of the demo, it kind of works. Okay, so just to recap. So Pinot, we've got tables. Also, we've got schemas. That defines the shape of the data. Tables link to a schema and indicate, hey, where's the data coming in from? You can have multiple tables with the same schema if you want, or you can, if you didn't want to do that, you could have individual schemas for each table. The reason why you might do the same multiple tables with the same schema is if you're playing around with indexes or different indexing strategies. You could say, okay, let's have a look if we use this index on the same schema, so same data. What happens? Like, do we see any difference? And then you could then get it to put the segments in that table as well. So that's the reason for that flexibility. So let's just create our table. So if we come back over here. So that's still loading some events. So if we create our Pinot table here, so we get a message, hey, it's successfully added. So Pinot comes with this tool called the Pinot UI, or Pinot Data Explorer. How big do we need this? Big enough?
Good. In the back?
Okay.
Yeah.
So you can kind of see, maybe, yeah, there. So you can see it's telling us, hey, you've got one controller, one broker, one server, one table, a tenant. We're just using a default tenant, but you can split the data by tenant as well if you want to, but we're not doing that in this example. We can then click this query console icon here, and then you get, it's pretty similar to what you'd be used to in a relational database, right? You can go and then query the data. It'll show you how many records there are. So you can see it's kind of going up this total docs here. It also gives you some metadata. How long has it taken to do that? How many servers did it query? How many segments? So it's done 50 segments to get this. We could change the query a little bit if we want to. So if we say, I don't know, user count star. So this is using is it calcite? I think it's called calcite grammar. So we can do group by and then let's say sort by count. Oh, sorry, order by. Star descending. So you can see that these are the top users that have been changing stuff. So you can see there, and this will become apparent. Like in the demo, a lot of the changes on Wikipedia are being done by bots, right? There are loads of them. They all have bot in the name. So there's the Q bot, the KR bot. I don't know what dig.log is, but nearly all of them, there are bots doing stuff. I'm sure if you're more knowledgeable about Wikipedia, you could tell me why are there so many bots. So if we just have a quick look around, so if we go into the table, so you see we've got a table and we've got the schema. It tells us how much data is in there, how many segments. And if we click on the table, we can then see, so you can go and change it if you wanted. You could update the table, change the schema. And then down here, we've got all the segments that exist. So you can see there are loads, right? So the way that these are named is it goes table name or schema name. Table name, underscore, partition number, underscore, and then it's just the incremental count. And then the last number is the timestamp of the first item in that segment. So everything here, everything that goes wiki events underscore 0 came from partition 0 from Kafka. So effectively, the data is sort of spread across those. And when it's querying them, it's kind of looking, it's able, for timestamp querying, it's able to filter, oh, I kind of know that it's not going to be in that segment because you said you wanted everything greater than 1252, and I know that all the data in that segment is before 1252, so I'm just going to ignore it. So it kind of uses the metadata that it has to do that. If we click on one of them, say here, you can see some metadata about it. So it tells you where you can download it, so that'll be pulling it from my machine. It tells you when did it create this segment, when did it end, and you can see it. So as I mentioned before, we've got 200 records in here, and it tells you in Kafka, what was the start offset, what was the end, and in this case it's saying it's done. And then if you look at the one with the highest number, that'll be the one that's currently consuming. Then we've got 200 docs. I'll just quickly show you one other thing that we can do. So if we can also zoom in, this is not from the UI, but we can, is it metadata? So we can have a look at, I think it's this one. So we can also see what. So this was Wiki Events, and then paste that in. So it also has this, oh no, that's not the one I wanted. So you also have a REST API where you can basically do everything that's available on the UI. Maybe it's that one I want. I'm trying to remember. There's a way that you can see like all the information about a segment, but it's not what I just did now. Let's have a look. Let's see if we can find it. Otherwise, maybe it's this one. Is it that one? Let's try this one instead. So if we do Wiki Events. Oh yeah, sorry, yeah, then you can give it a column and it will tell you. So if we quickly have a look here, what are the columns that we've got? So we've got ID and user. So let's put in ID. And what it'll do is if you tell it the columns that you want to look up, it'll tell you whether or not, what indexes have been applied on those columns. So we want, where's our time field? Is that down a bit? Oh yeah, TS, cool. So let's put TS in there as well. So there we go. So we get back.
Might have to make it bigger.
Yeah, I don't think I've got the right one anyway. So. Oh no, that's not. Yeah, sorry, this is not what I want. Hang on. Hang on. We'll give up on this part. I'll come back to this if we have time. So what I wanted to show you now was how you could go about connecting like this to like an end user application. So if I just minimize this, so we've built like a little dashboard using Streamlit. So this is what in case you haven't seen it, this is what a Streamlit application looks like. So you can import some libraries, and then you get, well, so in this case, ST basically means everything here is now interacting with Streamlit, and it's going to write it to the page. So I can say, hey, I want the page to be, oh, what have I done there? I want the page to be set, oh, close that. I want it to be set to this wide config, so that means it uses the whole screen. I want to put a header. Then this bit here is us connecting to Pinot. So we're using the Pinot DB library. So connect to Pinot, localhost 8099, and then send this query. So this is a kind of newish feature, so you can do aggregation with filtering at the same time. So it allows us to write a query that finds, so only look at events that happened in the last 2 minutes, and then count how many of them were in the last 1 minute, and then how many of them were in the 1 minute before that, so we can kind of compare like how many changes are coming in and how many changes came in the equivalent period just before that. And then we do the same for doing a distinct count for users who made changes, domain, and then we can kind of show it on the screen. And then what we're doing down here is we're building almost like changes per minute, like line chart, and then rendering it. So if I go back here, so if we do Streamlit run app v1. So what this does, you get this app here. So it kind of shows you, hey, these are the changes that are being made. At the moment, if we want to see it update, we've got to refresh it ourselves. V2 fixes that, but more or less you can see, like, so we've done, there's been 1,358 changes in the last minute compared to, well, there were 230 more than that in the minute before that. So interestingly, more domains have been changed in the last minute. But less for the other two. And then in V2, we then update it so that it actually automatically refreshes. So now it's automatically refreshing this every 2 seconds, and we could change that. We could say, hey, do it every 1 second. So every 1 second, it's basically going and running those queries again and updating the UI. So we've almost got like almost like a live dashboard now showing us how is stuff being changed on Wikipedia. And if you look on the right-hand side, that's the current minute, right? So it's always going to be slightly less than the others, but you can see it's creeping up. Oh, now it's back down to 0. And then we end up, so that's the second version. And then the third version shows some of the other stuff you can do. So that one there is kind of top level. So it's like aggregation, right? So like a lot of the stuff people are doing in analytics is, hey, I want to aggregate something. The next thing they want to do after they've done, they're like, okay, cool, I got the aggregation. I can get the picture of what's happening, is I want to do the drill down. So that's what we're going to do in the next one. So this is like the final version. So now we've got, I'll just minimize that for the moment. So you've still got the overview. We've got the stream of changes. So like it's coming in like these are all the changes that are being made. You can kind of see the timestamp they're made on the left-hand side. And then we can also zoom in and see, okay, who's making the changes? This is kind of a strange one. So it's like we've got the bots versus non-bots. So it's strange because it says that most of them are not bots. So it says 68% of the changes are not bots. And then if you look at the users who have made the changes, like nearly all of them are bots. But we can also break it down, so we can do some filtering, like to say, hey, which ones are bots, which ones are not bots, according to the stream. And what is strange is that you look at this, okay, so these have all got bot in the name, but if you come down here, you're like, well, how are you doing like so many changes? They've done 900, a person that's a theoretically non-bot has done 900 changes in the time that I've been talking, which seems implausibly fast typing. So I think these are probably bots as well. They just have somehow not been categorized as bots. So we can see who's making the changes. So that's one drill down. We can also drill down on where they're being made. So actually, majority of the changes are being made on Wiki Data, which is the RDF, like the RDF store, right? Wiki Data. Let's have a look. So this is like the structured data knowledge base. Let's pick. I don't know. Is this high risk to pick one of these? I don't even know who these are. Anyway, there's a person. So this is they have like a knowledge base of people, of things, and they kind of capture loads of metadata about them. So this is where majority of the changes are being done is to this, but weirdly by bots. So I'm not entirely sure what they're updating. And then we can see the changes that they're making. If somebody knows what 142 means, I have no idea. Like it always comes up as a category. Like they've got editing, categorizing, logging, making a new page, 142. I don't know if it's like some bug that sneaked out. They've got this event type 142, and it always shows up there. And then finally, we can drill down by user. So I'm just going to turn off the auto refresh. It's a bit easier to do the drill down by user. So this would be like a more interactive drill down. So there we were like drilling down by one type. Here we're actually specifying what exactly is the thing you want to drill down. So you can see for each user what changes are they making. So that's dig.log. This is the SLDST bot. I'm trying to find somebody who's done something more interesting. They're all changing just one thing. Oh, this person's done. They've done some categorizing and some logging. So hopefully you got an idea. So so just to remember, we put the data into Kafka. We've now got it. We've almost now we're able to now query Kafka, and Pinot keeps the data there itself. You can set a retention on the real-time data, but you can then move real-time data into into an offline table. And so one of the newer features being added to Pinot is the ability to use tiered storage. So I could store like my up-to-date data, like on really, really fast storage, and then my older data I could just store on S3. And so like there is now a feature that you can go, hey, I want to go and like if I'm looking for really old data, I'll query that through directly on S3, and if I'm using newer data, it's going to be on instant storage on a machine. I'm just going to come back to the slides now. I realize I've been talking for a while. And just quickly give you a rundown of, we've got 8 minutes. So as I say, Pinot's storing data in segments. So imagine these are the segments for each of the partitions for one table. So they would all be there. And then this is the way the segments break down. So at the heart of things, it's a column store, right? So all the values for a column are being stored next to each other in memory. So if you want to get all the values, if you want to do a count on a column, aggregation on a column, it's like just scanning down like all the values in the same column. So it's generally fast for that type of stuff anyway. But then on top of that, you can add indexes if you want to make it faster. And indexes are used. Majority of them are being used for, hey, I want to filter by something. And so you've got all this sort of standard stuff. So we've got the range index, we've got a null value index, there's a Bloom filter to filter out where I'm looking, and there's text indexing, JSON indexing. It's using Uber's H3 geo indexing. And then the last one is actually a selective pre-aggregation. We'll go into a bit more detail about that in a sec. So just to show you what does it mean, I don't think this is not particularly unique, but just so you can see how it works. So with the scan, we're normally going, hey, I've got a document, tell me what the value is. With the inverted index, we're saying, hey, I want to find a particular thing, tell me who's got that value. So i.e., I want to find all the rows, like all the documents that have the country Canada, and it's like, hey, here they are. And these are stored like in a compressed bitmap, so it's like it's optimized for looking it up. And if you said, hey, I want to find all the values for Canada and Japan, it'll just go, okay, well, I get both of those and give you back all the documents. And then so each row has an ID, and then it would, if you then said, hey, I want some other fields or some other columns, it could go and look those up by that ID as well. So that's an inverted index. And then just one more to look at. So this is what this is called a sorted index. And so the idea here is that everything with the same value is next to each other in memory. And so it means if I say, hey, I want to find all the values of the US, it's like, okay, cool. I zoom into the memory map file. I start at positions 101. I go to 300. I just can read it all into memory. Pinot tries to apply the sorted index automatically to stuff. So when a segment is flushed from being in memory to being on disk, it tries to automatically, like it basically scans through every column and says, hey, can I sort you? If it can, then it sorts it. But you can also say, hey, I want to sort a specific field as well. And then it will sort that field explicitly. But it will then go and look at all the other fields and say, hey, can I sort you as well? So it's kind of applying like almost some pre-indexing optimization for you. And then finally, yeah, I guess this is the other one. So this is the StarTree index. That's the name of the company that Karin and I are working for. And this one is almost sitting between like indexing and pre-aggregation, or like cube kind of workflow. So you can sort of indicate, hey, I want to apply like pre-aggregation to these fields or these combination of fields because these are the ones that people are querying the most. But I don't really care like about those other ones. You can just go and query those ones normally. So you're kind of trading off space versus time, like quite almost deliberately, explicitly. And then there are also like some other optimizations that are being applied along the way. So it's working out like where like there are optimizations at the storage level. So we kind of talked a little bit about that. There are then optimizations at the filtering level, which of those different indexes. So are we going to scan it? Are we going to use an inverted index? Are we going to use a JSON index? Or are we going to use a StarTree index? And then finally, when we're post-filtering, so I take the data and do something with it, if you're using the StarTree index, it's kind of pre-done some of that. Then even if you're not using that, Pinot is keeping track of metadata of counts of stuff. So it doesn't necessarily mean it's scanning every single time. And then when it's working out which server should I query, it's applying optimizations at that level as well. So it's like, well, I don't need to go to that server, so I'm just going to ignore everything over there because I know that all the data I'm interested in is sitting in these segments and they're over on these servers here. Back to Karin.
Okay, so basically, I feel like this slide doesn't really need a lot of description, but the combination of streaming system, you can use Kafka for this specific use case, and Pinot can be used for pretty much like any real-time analytics or user-facing real-time analytics use case. And also, so Pinot, it was originally developed at LinkedIn, actually similar to Kafka. And there's a lot of companies, there's over 100-something companies that are currently using it. The community is growing pretty quickly. I should have put a comparison of how it's grown over time. But in terms of performance, like some of the biggest Pinot clusters are ingesting over 1 million events per second. And then queries with over 200,000 queries per second, still maintaining millisecond latency. So it's very performant. And if you want to get started, well, that's the Pinot docs. And here's the takeaways. Real-time analytics let us create applications that gives users actionable insights. Properties of the systems, the 3 things you need to do: be able to ingest data, query it fast, and do it at scale. And then the combination of the 2, Kafka and Pinot, are a really good combination to achieve it. And that's our talk. If you liked it, please tweet about it and tell the DevOps folks that you liked it. And we'll take questions. I think we have 3 minutes.
We've got a big red screen now.
Right, 3 minutes left.
Yeah? Do you need to take the microphone?
James?
The microphone's coming.
Over there.
Is Pinot backed by like a database like RocksDB, or is it purely implemented within Pinot itself?
Yeah. It's purely it's got its own custom storage layer. Yeah.
Cool. That was quick.
Yeah.
We're making sure to send him all across the room back and forth. So
Yeah.
next time this side.
Next question down in the front.
To the farthest angle we possibly can.
Get some walking.
My question is, how would you compare Pinot to its competition, such as ClickHouse or Druid? What are its pros and cons?
Yeah, I guess you're asking a tricky question, given that we work for one of them. I guess the StarTree index is something that is unique to Pinot, but otherwise, yeah, I guess that they are kind of attempting to solve the same problem, maybe just in a slightly different way. I'd say some things that people tell us they like about Pinot are in the community, when they come with a question, they get the answer generally really quickly. But so that's what people tell us. I mean, but technology-wise, I don't know the other two really well.
Well, the other things that I've heard is, I mean, there's like a lot of, if you Google it, you can probably find a lot of resources that were written by the community. So a lot of people say Pinot is more performant. And also, some of the other things I've heard just from my community members is that, like something like Druid, for example, like it was built a long time ago and wasn't really like built for the cloud. So this was, with that in mind. So I think that that's something that's also at least a noticeable difference from what I've heard from community members. So.
But now you have to ask someone who works on Druid the same question.
Right, that's actually
like,
good.
we're talking rubbish.
So yeah. Any other questions on this side of the room?
Come on.
All right, time's up.
They'll be like, what's your name? Just so we can get.
Ask us what our name is. Our name is.
Time's up.
Yeah.
Thank you very much.
Thank you, guys.